Math 7 learners. Today we will continue with our lesson for the fourth quarter, which is on the types of graph. By the way, this is Teacher Mary Jane, your math teacher. First, let us look at the definition of graph. A graph is a visual representation of a set of values in relation to another set. It is used to present data being presented in tabular form. It is also defined by Merriam-Webster Dictionary as a diagram that represents the variation of a variable in comparison with that of one or more other variables. The important features of a graph are the title of the graph and the two elements or variables that are being analyzed. In our lesson for today, we are going to learn about 5 types of graph. The first one is the pie chart. The second one is the bar graph. The third one is the line graph. The fourth one is the histogram, and the fifth one is the ogive. So let us look at each of those graphs. The first one is the pie chart. It is represented by a circle divided into parts. It also shows the relationship among parts, as well as the relationship of a part to the whole. The data are presented in percentage form and represented in the circle graph by an equivalent fractional part of a whole. In this diagram, you can see an example of a pie chart. This pie chart has different parts: the title, the labels, and the legend. These parts are important for us to easily analyze and to give descriptions to the data presented. Now, how do we construct a circle graph? It says there, to construct a circle graph, let us recall the lessons on measure of central angles. In the example below, the percent rate for each chosen ice cream flavor is given. The rate is multiplied by 360 degrees. Why 360 degrees? Because it is the measure of one full circle. It means that we are going to divide the whole circle into parts depending on the percentage. For example, for mango, since it is 20%, so we are going to multiply 20% times 360. In the next column, you will see 20% was written as a decimal. So for us to multiply a percent by a number, we have to first change it into decimal. The equivalent of 20% is 0.20. Multiplying it by 360 degrees, the result is 72 degrees. The second flavor is Rocky Road, and it is 40%. Again, 40% is equivalent to 0.40, and when we multiply it by 360 degrees, the result is 144. We do that with the other flavors, ube, mocha, and tinapa. And if we get the total of that, it must be equal to 360 degrees. Given that data, we can now use a protractor to determine the measure of each sector of the circle representing each item in terms of degrees. So in our answer a while ago, mango is 20%. So that is the 20% of 360 degrees is 72 degrees. It means that this angle measures 72 degrees. The same for the others. For the Rocky Road is 40%. Multiplying it by 360, our result a while ago is 144. It means that this angle measures 144 degrees. And as I have said a while ago, the total measure of these angles is 360 degrees. Now, if you want to analyze the graph, we can continue by determining the number of students who chose a particular flavor of ice cream. When we are given the total number of students, we can easily do that. For instance, the total number of students is 60. So we simply multiply the percentage by the total number of students. Here is the result when we do that. For mango, let's say, for example, 20% of students like mango, and there are a total of 60 students. So 20% of 60 is equal to 12. It means that during the gathering of data, 12 students chose mango flavor. For Rocky Road, 40% of 60 is 24. That means that 24 students chose Rocky Road. For Ube, there were 15 students. For Mocha, there were 6 students. And for Tinapa flavor, there were 3 students who chose it. Let's look at another example of a pie chart. So the title of this pie chart is A College Student's Budget. A college student has totaled his expenses for the last school year and represented his findings in a circle graph. Here is the result. Now, I want you to observe the graph as we answer the questions that follow. For question number 1, which 2 items account for the greatest expenses? Of course, the answer there is the house rent and food. House rent is 30% of the budget and food is 20%. For number 2, what percent of the budget is spent for food? And the answer is 20%, as you can see in this label. Question number 3, what percent of the budget is saved? So we look at the savings, which is 2%. Number 4, which 2 items incur the same expenses? And the answer to that is tuition fee or books and cell phone load, because they are both 15% of the budget. Next question. If the yearly allowance amounts to 150,000 pesos, how much is spent for each item? So for us to do that, we simply multiply the percentage for each item by the total amount, which is 150,000. When we do that, here is the result. House rent is 30%, food 20%, tuition fee or books 15%, clothing 10%, cell phone load 15%, utilities 8%, and savings 2%. They were all multiplied by 150,000, and here are the results. As you can see, house rent gets most of the budget is spent for house rent, which is 45,000. So that is the importance of graphs. We can easily identify data, or we can easily present data using graphs. The second type of graph is the bar graph. A bar graph is used for making direct visual comparison of data. The bars in the graph may be drawn horizontally or vertically to present or to represent the information. Here is an example of bar graph with its parts. We have the title. Once again, the title is very important because it is a way for us to determine what the graph is all about. We also have the bars. So in this example, these bars are drawn horizontally. I mean vertically. Then we also have the categories, and then our scale from 0 to 8, and then the x-axis label, which is the favorite color, y-axis label, which is the number of students. So those are the different parts of a graph. Here is an example. The data on the charity donations of each grade level in a high school is shown in a graph or in a bar graph below. Once again, I want you to study the graph and observe the information given as we answer the following questions. For question number 1, what information does the graph provide for you as the reader? That question pertains to the title of the graph, which is the charity donations of each grade level. Number 2, give an approximation for the charity donations of each grade level. So let's look at the graph. By the way, this is an example of a horizontal bar graph. For grade 7, it is approximately 21,000 pesos because it exceeded 20,000. This line is 20,000. It exceeded a little, so let's add a little. So it's 21,000 approximately. For grade 8, it is exactly on this line. So it is exactly 25,000 pesos. For grade 9, it is 30,000. And for the grade 10 students, the total donations is 40,000 pesos. For grade 11, it is 15,000. And for the grade 12 students, it went past through 20,000, more than that of the grade 7. So let's add another 1,000. So that is 22,000 approximately. For question number 3, how do the two largest charity donations compare? Approximately how many thousands do they differ? As we can see in the graph, the two largest donations are from the grade 9 and grade 10, which is 30,000 pesos and 40,000 consecutively. Okay, but the question is about their difference. So we simply subtract the two. 40,000 minus 30,000 is equal to 10,000 pesos. So that is the difference between the two largest charity donations. Question number 4, which grade level has the greatest charity donations? Obviously, it is the grade 10 students who gave a total of 40,000 pesos. Let us look in this another example of bar graph. The bars in a bar graph can also be drawn vertically. Presented below is a multiple vertical bar graph. And let us analyze that graph as we answer the questions that follow. For question number 1, says there, what does the graph tell you? It means that it is asking about the title. Our title is the SIM card used by students per grade level. Number 2, what does each type of bar represent? So each bar represents the different types of SIM card. So for green, it is globe. For the brown, lighter brown, it's smart. Darker brown, talk and text. Gray for sun cellular. And then the bar with a red border is for non-subscribers. Question number 3, which kind of SIM card has the greatest number of student subscriber? We can easily determine that by looking at the graph. So here, this SIM card gets the most subscriber, and that is the color for smart. So if we can say that most of the students are subscribed or have uses the smart SIM card. Question number 4, what kind of SIM card has the least number of student subscriber? Well, looking at our graph for the grade 7, it is this SIM. For grade 8, there's none. Okay, so obviously it is the gray SIM card, and the gray SIM card, based on the legend, is Sun Cellular. Means that the students or the list, the SIM card which has the least number of subscribers is Sun Cellular. Question number 5, which grade level has the greatest number of non-subscriber students? And based on our graph, it is this grade level, okay, and that is grade 12. It means that the answer to question number 5 is grade 12. The third type of graph is the line graph. A line graph is used to show changes between two quantitative data. Usually, one of the quantities under consideration is time. Once again, usually we use a line graph to show changes over time. The relation between these two is graphed on a rectangular coordinate plane. The quantity time is usually plotted along the vertical axis. Points are plotted based on the relationship of the quantities and those points reconnected by a line. Here is an example of a line graph with its parts. So here is a title, and then we have the label for the horizontal axis or the x-axis, the label for the vertical axis or the y-axis, and then we have here the scale. The next one are the points here, which are connected by line segments. Let's look at the first example. Once again, we will answer some questions based on this graph. Question number 1, what two quantities are being considered in the line graph? This question is simply asking about the labels of the x-axis and the y-axis. So for the x-axis or the horizontal axis, these are the months, and for the y-axis, it is the electric consumption in kilowatt hours. So those are the two quantities being compared or being considered in our graph. Question number 2, when did the highest consumption occur? So let's answer that first. And the peak is in this month, which is in the month of May. So the answer to that first question is May. On the other hand, the lowest consumption is in this month, which is in the month of November. Question number 3, which month show the same amount of consumption? So let's look at our graph, and we can see that this month and this month shows or have the same consumption. So it is the month of March and July. So our answer is March and July. Question number 4, between which two months was the greatest increase or decrease in consumption greatest? First, let us answer the greatest increase. The answer is from this month to this month. So you can see it is a very long line going upwards. So the greatest increase is from November to December. On the other hand, the greatest decrease is from this month to this month, which is from October to November. Here is example number 2. Once again, let us analyze that as we answer the questions. Number 1, what are being compared in the multiple line graph? Once again, for the y-axis or for the x-axis or horizontal axis, we have the year, And then for the y-axis or vertical axis, we have the production in 1,000 metric tons. So those are the two variables we are considering in this graph. Question number 2, what does the vertical axis represent? The horizontal axis. So same answer to that of number 1. Okay, we just label vertical axis focuses in the production of crops. Horizontal axis is on years. Question number 3. What was the approximate production for each crop in the beginning year? Our beginning year is in 2015. So let's start one by one. Our products are the following. Kamote. Approximately it is between 0 and 20, so that is approximately 10,000 metric tons. Turnips is in this line, so it is exactly 20,000 metric tons. For onions, it is the same, it is in this line, so it is also 20,000 metric tons. For corn, it is here, it is aligned in 40, so it is 40,000 metric tons. And for palay, it is between 40 and 60, but it is higher than the half, so we can approximate it as 55,000 metric tons. Okay, for question number 4, which two crops followed almost the same trend of increase in production for several years? So we simply look at the graph and we can see that the red line and the dark orange brown follows the same pattern, and those two are represented by palay and corn. It means that the answer to question number 4 is palay and. Question number 5. In what year was the production of palay, corn, onions, turnips, and kamote the greatest? Let's answer that first. So kamote, for kamote, the greatest production is in this year, that is 2017, and also in this year, so that should be 2017 and 2020. For the next crop, for turnips, it is in this year, so that is 2020. For onions, it is also 2020. Same with corn and palay. The kamote crop, and for the next question, it says there, which crop showed a very slight increase? And the answer there is the kamote crop, because it showed a very slight increase from 10 to 24. That is the answer to our last question. The fourth type of graph is the histogram. The histogram is a graphical display of data using bars of different heights. It is similar to a bar chart. Remember, it is similar to a bar chart, but a histogram groups numbers into ranges and shows no gaps between the bars. The height of each bars shows how many falls into each range, or simply the frequency. The histogram is constructed as a sequence of vertical rectangles. Each rectangle is drawn with its base equal to the class interval and a height corresponding to the class frequency. Here is an example of a histogram. Once again, it is similar to a bar graph, but a histogram has no gaps. It means it is continuous because it represents a continuous set of data. So we have here the title, we have here the intervals for the x-axis, the intervals for the days of operation, in the label, and then the frequency is in the y-axis. Here is another example of a histogram. Let us look into each part of a histogram. So the title, the title describes the information included in the histogram. The x-axis or the horizontal axis are intervals that show the scale of values which the measurements fall under. For y-axis, the y-axis shows the number of times that the values occurred within the interval set by the x-axis. And of course, the bars, the height of the bar shows the number of times that the values occurred within the interval, while the width of the bar shows the interval that is covered. Again, here is, for example, in this graph. So for the first bar, it means that the number of respondents or number of teachers that belongs to this range, that is from 1 to 3, is 2, since the frequency is 2. The number of students that fall in this scale is 2. For this scale, it is 4. For this, it is 8, and so on. Now, why are histograms important? So, creating a histogram provides a visual representation of data distribution. It is used to summarize discrete or continuous data. Histograms can display a large amount of data and the frequency of the data values. It provides a visual interpretation of numerical data by showing a number of data points that fall within a specified range of values called bins. Those are the importance of a histogram. And there are different distributions of a histogram. The first one is a normal distribution. In a normal distribution, points on one side of the average are as likely to occur as on the other side of the average. So, as you can see here, it is low in this part, same in this part, and then the peak is in the center. Okay, so that is a normal distribution of a histogram. Now, here is another one. We have a bimodal distribution. A bimodal distribution, in a bimodal distribution, there are two peaks. So here is an example. Here is the first peak, and then here is the second peak. In a bimodal distribution, the data should be separated and analyzed as separate normal distributions. So for instance, you have this type of a histogram, so you should divide it and analyze each of this as separate or as a separate normal distribution. The third one is a right skew distribution. Here is the diagram for it. A right skew distribution is also called a positively skewed distribution. In a right skew distribution, a large number of data values occur on the left side, with a fewer number of data values on the right side. So it means that most of the respondents or most of the data falls under the range on the left side. That's why it's called a right skew distribution. A right skew distribution usually occurs when the data has a range boundary on the left-hand side of the histogram. For example, a boundary of 0. The opposite of a right skew distribution is a left skew distribution. Here is the illustration. A left skew distribution is also called a negatively skewed distribution. In a left skew distribution, a large number of data values occur on the right side, with a fewer number of data values on the left side. A left skewed distribution usually occurs when the data has a range boundary on the right-hand side of the histogram. For example, a boundary such as 100. So this is an example of a left skewed distribution. And the fifth type of graph is the ogive. The ogive, or an ogive, sometimes called a cumulative frequency polygon, is a type of frequency that shows cumulative frequencies. In other words, the cumulative percent are added on the graph from left to right. An ogive graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. It's very similar to a histogram, only instead of rectangles, an ogive has a single point marking where the top right of the rectangle would be. So they are similar. An ogive is similar with that of a histogram. The only difference is that the histogram shows or uses rectangles, and for ogive it uses points. Here is an example of an ogive. You might mistook it for a line graph, but if you will see the label of the x-axis, you will see that it has a range. So 1 to 9, it means that it is a continuous data. That's why it represents a cumulative frequency. Okay, so 10 to 19 and so on. That is the difference between an ogive and a line graph as well. Okay, so there are class boundaries or ranges on the x-axis. We have here an example. It says there, draw an ogive graph for the following set of data. And when we draw a table for that, we have here the class boundaries. The frequencies are the following. And then the cumulative frequency are as follows. And when we get the percentage, it is as follows in the fourth column. Given that, we can use the Microsoft Excel to input the data, and here is the result for our ogive graph. We can be discussing more on this for higher mathematics. Okay, so as long as you know the difference between the different types of graph, then we are good to go. Let us recall. Today we have learned about the different types of graph, the pie chart, which shows the relationship among parts as well as the relationship of a part to the whole. The bar graph, which is used for making direct visual comparison of data. The line graph, which is used to show changes between two quantitative data and usually involves time. Histogram, it is similar to a bar chart, but a histogram groups numbers into ranges and shows no gaps between the bars. The fifth one is an ogive, which is sometimes called the cumulative frequency polygon, which is a type of graph that shows cumulative frequency. Thank you so much for listening to our discussion for today. Our next lesson will be on the measures of central tendency involving ungrouped data. Thank you and goodbye.